How's it doing? My name is Quigley. I've been a senior UI engineer at Swrve. I've been working front end since about 1999. Built my first website around then. I've done a few things since, but I always seem to come back to front end. I've been working with React and Redux for about 3.5, close to 4 years. Not Angular before that. So I like finding the right way of doing things, kind of the right solutions. Yes, it's actually finding the easy solutions is probably more than I like to find. So I think with front-end development, you kind of really have to focus. If you can simplify the tooling, you can focus on what the front end is meant to be doing instead of why, instead of how the front end is meant to be doing it. My team in Swrve, we got all the user-facing dashboards. So about a year ago, I guess now, we were building our apps with originally Ember. We were transferring over to fully React, using Redux as a state layer, which also became sort of an API cache. You know, everyone would put their API calls in there. It was becoming quite a large, sort of unwieldy thing. And with that, we started looking at GraphQL, and we had a few different APIs, and so we started bringing them all together. So, in terms of the front end, how to build a good front end, it should be easy and quick to change. Because I think, like, when I kind of see it as the back end should be pretty static. The API layer should be flexible. The front end should change as easily as possible. You can make small changes to the front end and present the same data to a user in a way that they're going to buy into a lot easier. So just a little bit about Swrve. So Swrve, in my understanding as a front end developer, we provide a lot of SDKs that are integrated into apps. We collect lots of data from those apps. I think there's about 10 billion pieces of data captured. And then we use that data to help customers kind of target their users effectively. So as I said earlier, my team, we focus on the front-end dashboard. So what this talks really about is how GraphQL is going to affect a front end that you've already built or a front end that you're going to build in the future. So this is a little segue. I know this is a microservices group. Apollo is the client that we use to write front end GraphQL work. So they've just released Federation, which is a tool for, I know very little about it other than what it does, and it's a segue. Right? But Federation basically allows you to combine lots of microservices together and present a single graph to use and interact with. So I think before this you had to use schema stitching, I believe it was called, which I think was a little unwieldy and difficult, but from what I've read and what I've heard, this seems to make that process very simple. So I think that my talk would be like, if using GraphQL with microservices is something that's becoming more simple. My talk is really to maybe give you a little bit of detail about all of the front-end considerations about using. So a little bit about our dashboard. At the moment, we don't have microservices as such. Our dashboard is built on top of a Ruby backend, a Ruby Rails backend. On the front end, we use React, we use Apollo client, obviously. We use Swrve a lot for our component testing and building, and we use Jest and what we call React testing library in most of the development. And as I said earlier, we're migrating some small parts of our system still from Ember. So the side effects, if you do decide to use something like GraphQL to your front-end app, if you have a front-end app already, and let's say your front-end app is built with something like React Redux. It's not necessarily a perfect fit. They're kind of different, even though they seem quite the same. There are some, there's some cons, but if you did decide it's mostly a really good idea. I think we've really enjoyed it. Here, expect lots of refactoring your code if you are going to do it. And if you're a building a new front end with this, it takes a little bit of a shift to use it right. You can get it working very, very quickly, but there's quite a lot to understand in terms of caching layers and stuff to really make it work well. So let's just set this down. So in this, I want to kind of cover the effect it's going to have on your state management, your folder structures, your overall app structure. Just want to talk a little bit about testing and mocking of your data, and then I just want to cover how does the team? We have a team of 4, going up and down to 8 developers, and how that team works together, and how when new developers come in and out, how they actually are able to fit into the architecture and to the systems that we have, and how easy they find the code to pick up and start working with. So, just want to give a little brief history. I'm not sure how many people have experienced front end here, but a lot of React apps these days are built with React and Redux. So Redux was I think in the documentation they call it a predictable state container for JavaScript apps. So it's essentially a global state manager, and most of the time it ends up being a sort of a self-rolled API cache. So you're making your API calls, you're putting them somewhere, and then when you have all your data, you're going to build your front end. So the pros of it definitely allows you to build really complex apps. It's very easy to build. There's some really great developer tooling in Chrome for it. And the reducer structure, or the reducer approach, is brilliant with React, because React re-renders itself and it works best when you're working with immutable data. The cons of it are you self-roll it. So it can be implemented in many ways, and quite a few of them are bad. And quite often it's the first thing people do when they build an app. They lay out this state layer, and then they build everything on top of it, and it's probably the hardest thing to change. If there are any kind of defects or problems with it, you're sort of stuck with them. And the saying is it's easy to use, but kind of difficult to master. I've worked with Redux apps for a long time. I find that over time they start to become very rigid and sort of bloated. And there's lots and lots of boilerplate code. You've got all of your actions, your reducers, your code base is full of boilerplate. And it's an app level state as well. So essentially, when you build your app, if you decide that maybe your app's getting too large, it's kind of difficult to split your app. It's kind of difficult to say, this is so big now that I'd like to have 2 apps, or I'd like to load this part of the app on a different URL. But because you have this one global state, it's sort of the app just becomes the easiest decision is always to we just keep building within this state. And you end up with a mix of local state and API state. So your local state, where you're, let's say, collecting a bunch of data before you've saved it, you're using that to derive the UI and how it's built. That's all stored in it, but then you're also storing lots of results of API calls. And each one of those is triggering re-renders, and over time it can become way less performant. And again, as I was saying, it's not great for code splitting. So, probably should have showed this after. But once we introduced GraphQL, what we ended up with was very defined layers within our app. The codes have no connections between any of these components, because there's no code inputs or connections between them. We were able to write our features fully isolated from each other. So if we did need to move stuff around or split things out into different places, split things out into packages. We could, as long as these exist within the Apollo client, they'll work. They'll pick up. You can run them. So, how does Apollo client replace something like Redux? It took me a little while when I introduced it first to kind of understand that. I think I read a lot of the people talking about GraphQL, and they're saying, "Oh, you delete half of your code. It's so much easier." I didn't initially understand that it was what it was doing behind the scenes. So it basically, Apollo client and a React Apollo, it uses the Apollo schema, or the GraphQL schema, to build a normalized state. And it's the same state that you would have built with Redux, but it builds that for you. And then that's always reflected by the schema. So as your schema updates, your state updates. So obviously the pros of that are you just cut out huge amounts of code. And code you're not writing is code you're not testing, is code that doesn't have bugs in it. You can still use kind of Redux style reducer structures to manage local states, but they become much more focused on what they should be, which is just UI data or state that hasn't been saved to a server. Your API caching is handled out of the box behind the scenes by the cache. One thing we also found was our state management. When we did have to have kind of broader state management, it became much more focused on two features. So we were able to sort of have separate features within our code base, which were a lot easier to work with, a lot easier to test, a lot smaller. It plays really well with React hooks, which I'm sure many of you know about, and it's new APIs in React that again simplify a lot of the approaches. And yeah, your apps become much easier to break up, split, maybe turn into packages, do different things. So I'm going to give a little demo. So, cool, that worked. So, this is a little app I just threw together a little hour last night, which is built with GraphQL. It's a React app, obviously. It's built with GraphQL. If I can just open up, it's really, really hard to use apps like this. So bear with me, I need to turn around. So there's a really nice little plugin for Chrome, which gives you access to the cache. So a few things about this app. This is all of the data in here is fully mocked. So this schema is something I just grabbed off the internet last night. It has some tweets and some users in it, and it just defines like a user tweet sort of schema. So with this, I'm able to make all my queries off the schema. So when my front-end app is making queries, it's hitting this cache. It's I'm able to lock all of this data and pull it from it. I can make multiple queries. So I can't quite see it there, but I can make multiple queries, pulling in further data. All of that data is going into my cache, being normalized by the IDs. So my cache will build up a sort of starting with partial pieces of the API data that you pulled in. It'll start building those up. So further calls to this will go to the cache before it'll go to the API. And then there's quite, you can control all that by caching flags and what level of caching you want. So I'll just jump really quickly. So I'm trying to throw this over. So I'm just going to give you a little look at the code. So just how this works. code. One moment. Sorry about that. Okay. So this is our little storybook, which is a little helper thing we have. Which, oh, that's my Spotify. Okay, so this is a super simple little app, and it all runs on this schema file. So very simple. You can add to this. If I added a value here now, I can make it'll still automatically mock that value. It may have a very generic name within it, but if I put a string in there, it'll still come back with a string. If I put an int, it'll come back with an int. So I put a little client here, which runs some of these methods that come with upon client. In this case, I pull in my schema, I pull in this mock. Generally, always have to mock a date, so I pull in this little mock file which I've created here. So there's a tool called Faker that works really well with this. So essentially, all I have to do to mock all of the data within the app is create these overs. They're just simple functions that are returned from an object that mirror the shape of the schema. And with that, my client, once I plug that into my Apollo client, I get that data back whenever I make any API calls. I can also set that up to accept mutations as well. So let's say I push some data, I can set that up to return mock data as well, with still populate my cache, so I get all of the sort of front-end sort of features of having an API live. So this is really useful when you're developing. This is very fast and very connected. Being able to sort of, I guess, forward mock those schemas and sort of design out how your app's data should be before you get it actually built in the back end is really, really valuable. It's a great way for like front end and back end to communicate and talk to each other and find the right approach to doing things. What else? This can also be used for testing. So your tests, I think of the name of them now, the credit card company. I know they're doing a lot of this. Irish credit card company. They're doing a lot of this stuff with their testing now, where they have mock schemas. You can pass just the piece of state that's going to affect that test, so you can isolate it down and go, okay, I expect this part of my UI to render this particular value at this time. You can control that. This could also return just as much mock data as you need, test data as you need. So it just really simplifies testing. So that's one thing. Also another little app, just to give you a look at something a little bit more. So we can get this small enough. Okay, not sure if you can quite see that here. Hang on a second. So this is a little graph app. So this was a really difficult app to build if we didn't have GraphQL, because in terms of building this for our customers, a lot of this data, so this is meant to show customer data. So a lot of the data that we were meant to show didn't exist yet because it's a brand new feature. So to actually mock out, to build a UI for data that doesn't exist, especially when it comes to graphing and data management, is really, really difficult. But we were able to sort of very simply, with probably about like 100 lines of code, create a completely mock API that returned all that data. So all these UI interactions are making API requests to the server, returning data. It's a full life cycle. So there's no code that we've written between this and an actual API call. So the chances of sort of creating even though this is mock data, the chances of that mock data being invalid data, and you know, is pretty slim. So a little bit more of that. You see why there's the countries. It's all coming from Faker as well. So I'm just going to jump back into some slides. Okay. So, yeah, the other thing I just wanted to, was talking about, which is testing. So, the testing becomes a lot simpler with this. We started using a thing called React testing library. So, you kind of follow that testing pyramid with lots of small unit tests for all the utility classes. On the far end, we have system tests, which are slow to write and difficult to manage. But with this approach, we're able to add something in the middle, which is sort of like a front-end integration style test, where we can use React testing library and this mock API, and we can follow all of the user paths through the UI, and we can test them, and they'll run at unit test speed as well. So we can have really detailed tests following every user interaction that the app is going to have written in those tests. All of those interact with our UI with the same data automation tags that our system tests do. So one of the pain points we had was whenever we were writing our system tests, would be that a front-end dev would forget to put the right tags on a button in a UI component. So the back-end dev who was writing system tests would have to come back, and we'd have to maybe do another release. It was just a slow process. System tests could take 2-3 days to create one system test. But with this kind of is like the guide rails for our system tests. We've got to, we always kind of know that our system tests are going to be easy to write because we've got all of the right tags on all of our components. So sorry, my computer wants to close itself. So, developer experience. Did I spot that wrong? Front-end devs are putting it up. Overall, all the devs, front-ends, all our API or dashboard devs who handle all the Ruby API stuff, we're all loving this. It's got lots and lots of advantages. The GraphQL queries are really well, they're self-documented, so we can open up the GraphQL Explorer and build our own queries as front-end devs, and the back-end devs really don't have to be involved in that. They can work ahead, building out schemas. We've got that communication there where we can both work on the schemas together and figure stuff out. But it sort of takes a lot of the tension away from kind of team interactions because we're all able to there's not as much waiting on each other to do things. In general, it's been a really, really good experience. I think we can put a lot more focus into just getting features out. Overall architecture of the app is much, much healthier now. It's much easier. The app's is not becoming more and more complex. It's as complex as the most complex feature, but the features are very separate from each other, which generally wasn't the case in the Redux apps. And that is pretty much me. So, any questions?
I'd hard to find a service like that at the beginning, because they might say, what's in it for me?
No, actually, because I think no, maybe I was very, very lucky. I think I did approach it right. I kind of set it to the right front-end dev or back-end dev, and kind of was like, this would be really cool. And he's the sort of person who was like very eager to try out new things. But when he started looking at it, he came back, I think, after the weekend, and he had like re-implemented half of our dashboard in it because he just got really excited and did it. So once people started working with it and sort of seeing the advantages of it, yeah, everyone liked it. I think there's a real sort of, I don't know, there's a tool called GraphQL which lives between, basically you get out of the box, which is a, bring it up? Yeah. It's basically a full tool that you can write queries, interact with queries, run queries against your entire graph. So you can basically, it becomes really, really valuable to the backend developers because they can test their data, what's returned. They can, you know, in our case, we were able to, you know, CMS were using it because we were able to, if there was something wrong with a particular campaign, we were actually able to go in and interact with the APIs even if the front end didn't exist and change things. And all of that is fully self-documented as the schema sort of outlines all of that. It's navigatable as well. You get full autocomplete within it. It's a really nice tool. And other things you get out of the box with that is that schema can be plugged into your linting. So when you're writing schema in your browser or in your VS Code or whatever, you will get linting and error warnings if you put something in that schema that's not there. You get autocomplete. That same linting then will tie in with your CI/CD. So you'll get CD failures if, let's say, somebody over here changes something to one of the schemas, it will fail in CI/CD because the linting will fail for you. So it's really nice.
Starting a project from scratch, do you feel this would be the way to go, or do you feel it's a pragmatic choice where you see yourself going back to Redux, or just this is level 0 from now on?
So I would kind of say I've never left Redux. It's like Redux is 200 lines of code. It's a sort of an idea rather than anything else. Hooks has come along. So Hooks has provided a lot of things in native React, and the context API is much simpler. They've used Reducer, which is essentially, so with those you can write a sort of a feature level Redux yourself, and you can self-roll it, and it's all of the same Reducer structures approaches. How it works with this is kind of different. You have to, there's a few little gotchas with it. You have to make sure you're you have to make sure that the life cycle of your state is between API calls, and it's cleared each time the new data comes from the cache. But we're just kind of getting our heads around how to use this now. You can interact with the Apollo cache in local state as well. So you can push stuff to Apollo cache the same way as you use an action to push stuff to a Redux state. And it's just not, it's not quite as intuitive as having as a Redux approach or the action approach, but it's something I think is really interesting. But yes, I would definitely go this over a purely React Redux approach. I think this is a lot of fun.
So do you make the request for service logs whenever the data pushes from cache to the API call? Because whenever you are pushing, do you log those service requests when the data pushes from cache to the API call, because you are pushing from the cache to API? The API will have its own service log request. But are you maintaining any caching request for the service log?
Caching for service logs?
Yeah. Means more sort of when the data pushes from cache to the API call, where you want to push, take the data from.
No, don't quite get you, sorry.
In terms of, you told about whenever your data pushes from cache to API call, you get the access to whenever you want to get the data from.
Yeah.
So you maintain any log for the service request when cache moves to the API call, that state, what I'm asking.
So when I make an API call, does it automatically go into the cache? Yes, yeah. So each query is kind of like I just jump back to the query. Sorry if I'm maybe. So here's that's a query there within a component. So this is grabbing the partial data from a tweet, and that's going into the cache as part of that particular object in the cache. So I could, at the very top level, I could pull all of the data in one query, and any further queries that are asking for the same data or data that existed will pull it from there, unless I invalidate that cache. sorry, I'm not answering the question, right?
Yeah, it answers partially.
Cool.
It's going to be a stupid question, but
It's okay.
just using GraphQL, a little bit of my understanding that it somewhat replaces the need for REST API calls.
It does.
So my question is, I suppose, if you have a web app that's consuming REST API, and you say you want to replace it with GraphQL, but you also need to expose those REST API endpoints to consumers else. Is there a way to actually maintain two apps or to...
So as I said,
Yeah.
a front-end dev, so I could give you a really stupid answer back. My understanding is there's no difficulty in having both. You know, it's the GraphQL. I know in our implementation, GraphQL just sort of sits between our RESTful APIs and the front end, and the schema. You know, I think you can write your own types. I know because we're using GraphQL or we're using Ruby on Rails. There's a Rails plugin which basically takes it creates that schema for you, so you don't have to build those yourself. But I mean, it's a middle layer. It adds typing, gives information to your API, but it's still I know our API is still multiple RESTful calls behind that.
Question is that the cache is what you call from your React thing, and this will eventually invoke a query object to do the query, the GraphQL query to the backend, right?
Yes.
Okay. How do you control performance so you don't have a cycling through 1,000 objects and you have 1,000 queries going back to the server instead of
Okay, so
a single batch query that gets everything?
one of the nice things about GraphQL, if you look at a bigger, more complex query, like these are all pretty small queries. I think the ones we have in 1,500 lines long. Maybe if I have a longer query. So here's the kind of longer query. So this is a pretty small graph, but in our system, we're pulling from, we're getting campaigns, we're getting variants, we're pulling different pieces of data from lots of different sources, and they all come in one single request, and then all of that gets cached. When it comes to mutations, you're sending data back up. I believe there's a lot of, if you send multiple mutations in one go, Apollo will put those all together, and it can. That's the thing about the graph. You can have a single mutation, which is what you push data with, is called a mutation. It's still just it's exactly the same as a query. So the same way as you can put multiple, you can request for multiple different objects within a query and multiple different things and build up sort of one thing. You can do the same with your mutations. You can build up like complex mutations that send all of that data in one go. So it's quite nice. Is that? Yeah. Cool.
How are you sure that your cache doesn't contain stale data?
So that's where it's kind of really down to the request you're making. So you can invalidate the cache very simply. So it's a sort of decision that you make. One of the things we do is we put sometimes we put a flag in data if we want to let the cache know that data has updated in some way. You put a timestamp if you want to do. They're just a lot of the time where this is really good is that let's say, like one of the things we're building at the moment is there's certain data we want to know is always fresh. So whenever we delete something, we make that request. We want to make sure that, so we're deleting it in this part of our app, but there's another page over here that relies on that same cache. So we want to make sure that that cache invalidates correctly. And so we manually sort of go, not manually, we kind of tell that to populate. When the return value comes back from that delete, we'll have like a tombstone, and we'll push that to the cache for that ID. So whenever we jump to that part of the user router, so whenever we jump to that page, because that page is coming from the cache, it will automatically, whenever we renders that page, it will pull its data again. It'll call the query, it'll see the data in the cache has changed, and then it'll pull that fresh data down. So there's, like, it's definitely something you have to manage, but all the tools are kind of there that you can manage it. And then what's kind of valuable is, like, so we've a form at the moment, and that form is generated by a config. And all of the incidental data to build that config, there's like four different objects that come from 2 different sources. I don't know why we did it this complicated, but all of that data is very incidental. You pull it once and it doesn't change. It's not going to change between, it's not going to change between, from one moment to the next. It might change once every week. So with Redux, we would have been, when we uploaded, we would be pulling all that data in and storing it in our state. And then we would have had a lot of logic in the form that used that would be reaching out to that top level state. So then you have all those imports between this form and that state, which is where your app starts to get kind of rigid, with all the imports between things. But with this, we've just basically got this little app that is pretty much self-contained. It does that query every time itself. It pulls all of that data with a single query. We know that every time that page renders or changes, that it's not pulling that data a second time unless we totally refresh the browser. So it makes the code building and the architecture of that really simple. It's like, get the data in the form, totally self-contained. Whereas before we were making API requests, making multiple API requests, and you're having promises, managing the calling of those, making sure this didn't call that data before this was populated. So a lot of that sort of just kind of magically goes away, and it's sort of like relatively self-contained little components. One of the, so that's where did it put out? But there's that report component. I mean, that fits inside a much larger, more complicated page. But we were able to develop that with mock data in a tool called Swrve, that's a really valuable part of this as well. I'm not sure if anyone's know what Swrve is. Probably it's a very front-end tool, but it's a tool that for developing components. So you can, so if you've got a big code base and every time you change something you have to rebuild all of that code, with Swrve you can just kind of import that piece of the code you're working on. You can use all of the mocking tools to mock that API. So then, and then you can create different stories that have different configurations and that. You can add these components called knobs, which are part of Swrve, which have sliders and inputs and user interactions. So that sort of becomes like this base that you can go, look, we built this component, products and design can interact with it and work it and use it. And you can do all that before you release to anything like that. So yeah, so that kind of isolation is really valuable for a front end.